All right, let's do a couple of practice problems and see how we do. So 36x squared plus 12x. Again, we're going back to last unit. This needs to be factored and then solved. We're trying to find all the solutions to the equation. So what goes into 36 and 12? Oh, look, there's an extra x in both. There were two methods I showed you guys for factoring this with the greatest common factor. Some of you can see it as just dividing 12x straight out. Some of you need to see it completely broken out. So I'll do it both ways. 36 could be written as 3 times 2 times 2. That makes 12 times 3, xx. And 12 is 3 times 2 times 2 times x. 12, 3 times 2 is 6, 6 times 2 is 12, there's my 12. 36 is 6 times 6, so there's my 36. What's in common goes out front. 3 times 2 is 6, 6 times 2 is 12, and an x. What's left over stays inside. Remember, if we used everything up, you need to do a placeholder 1, or 12x divided by 12x is just 1. So whether you see it as the division up at the top, where the 12x goes out front, 36 divided by 12 is 3, x squared divided by x is a plain x, 12x divided by 12x is just a 1. Whether you see it as the division or whether you like to see it stretched out, these are our factors. Now that we have factored this and they're equal to 0, now we're going to solve each piece. The first piece, 12x equals 0, can be solved easily by dividing by 12, and x is just equal to 0. Now wait a second. The last time we had a negative 16 out front here, I told you to ignore it. Why did we ignore it when it was a negative 16 and we're not ignoring this? If it has an x, it's one of my roots. I cannot ignore it if it has an x. I have to solve it. So this one has an x, so I solved it. Here's my first root, my first solution. Over here, I set this one equal to 0 now, and I solve. And there's my second solution, my second root. So x equals 0 and x equals negative 1/3. I got these solutions by solving by factoring. Step 1, factor. Step 2, solve each piece. And here are my solutions. Okay, look at this. This looks like the difference of two perfect squares. Notice 3 times 3 is 9, 4 times 4 is 16. So 3x plus 4 and 3x minus 4. Again, 3 and 3 makes 9 times 3 times 3 makes 9, 4 times 4 makes 16. We need 1 plus and 1 minus because there's no middle term, and we need those middle terms to cancel out. So now I have factored. Once I've factored, I set each piece equal to 0, and I solve. All right, let's look at the next one. Notice there's a greatest common factor. A 3 can divide out of everything. So 3 comes out, leaves me x squared minus 1x minus 20. And I can still further factor this polynomial inside here, where I go off to the side and I've got negative 20 as my c and negative 1 as my middle term b. What times what makes negative 20? And which one gets the negative? 4 minus 5 is negative 1. So x plus 4 and x minus 5 are my two factors. Notice that the 3, the greatest common factor, has no x. So we're going to ignore this. This doesn't mean anything. This is not one of my roots. But these, x plus 4 equals 0, have to both be set equal to 0 to get my two roots. And I solve, and I get the first root of x equals negative 4, and I get the second root of x equals 5. All right. For these next three, I'd like you to pause the video and try them on your own and then check it out. Okay, how'd you do? What times what makes 32 and adds up to 12? Hopefully you thought of 4 and 8. X plus 4, x plus 8, set each piece equal to 0. I got -4 and -8 as my two solutions. Remember, if the factors are positive, positive, my solutions are negative, negative. Okay, this one is not ready yet. This one I have to add 6 to both sides to get it into standard form. Now that it's equal to 0, now it's in standard form, now it's ready. What times what makes positive 18? 6 and 3 both get a negative to sum up to -9. X minus 6 and x minus 3 are my factors. Solve each piece by setting it equal to 0. All right, this one over here, -14 times 3. It's a really big number. 14 times 3, 12, 42. So what times what makes 42 and adds up to positive 19? This one may not come as easily, so let's write it out just in case. 2 times 21, 3 times 14, 4 does not go in, 5 does not go in, 6 times 7. Now that I have my whole list of possible factors, by the way, 8 doesn't go in and 9 doesn't go in. Now that I have my whole list of possible factors, I look to see which ones might subtract to give me 19. Notice the 2 and the 21. And if I just make this a -2, 21 minus 2 is 19. Notice there's a leading coefficient, so I get 3x minus 2 and 3x plus 21, but I need to reduce this second factor. So I get 3x minus 2 and x plus 7 because this can be divided by 3. So here's my two factors. Set each piece equal to 0. And I get -7 and positive 2/3 as my two solutions. All right, this one is also not in standard form. Let's subtract 6 from both sides. What times what equals -6 and adds up to 5? This is a positive 5, so I'm thinking 1 and 6. 6 minus 1 is positive 5. So my two factors, make sure you can see this, would be 2x minus 1 and 2x plus 6. And which one can be reduced? This one right here can be divided by 2. So I get x plus 3 and 2x minus 1 is equal to 0. So all this work to factor and set it equal to 0, now it's ready to be solved. My first solution is x equal to -3. My second solution is x equal to positive 1/2. Can you solve those and see if you can come up with why those answers are true? X equals -3 and x equals positive 1/2. Okay, this one and this one are now in a different format. Anything that's to a power of 2, these are already factored, right? But it's a perfect square. This to a power of 2 can be solved when it's equal to a constant like this is by just taking the square root of both sides. So if I take the square root of both sides, I'm going to get 2x plus 3 is equal to 0. 2x plus 3 is equal to 0. So minusing 3 from both sides, 2x is equal to -3, divided by 2, x is equal to -3/2. Remember that when it was a perfect square, it's called a repeated factor because it's only going to touch one root on the graph. What do I mean by one root? I mean, picture a dot at -3/2 and picture a quadratic that only touches once, right at -3/2. That repeated factor of the perfect square is just going to give us one solution or one root. Okay, let's go do this one. Square root of both sides. We get 2x plus 3 is equal to, hold on a minute, the square root of 100 is plus or minus 10. The square root of 100 is plus or minus 10. So two things are going to happen here. 2x plus 3 could equal positive 10, or 2x plus 3 could equal -10. And now we solve both of these situations. Minusing 3 gives me 2x equals 7. Dividing by 2, x equals 7 halves. So 7 halves is my first root. Minusing 3 gives me negative 13. Dividing by 2 gives me negative 13 halves. Your two roots are 7 halves and negative 13 halves. All right, last guy, way over here on this page by himself, is just a little radical that needs to be simplified. We take the square root of both sides and we get that x is equal to the square root of 28. And we're like, uh-oh, this is not a perfect square. So we need to break the 28 up into factors, and we're on the hunt for perfect squares. Well, check it out. Root 4 is a perfect square. So the square root of 4 is 2. Root 7 can't do anything. Now it's done. This is called the exact answer. We just simplified the radical. Oh, look at all this extra space. Let's do a couple extra. X squared is equal to 72. Take the square root of both sides. X is equal to, square root of 72 is not a perfect square. Let's break it up into factors. We're on the hunt for perfect squares. 72 would be 2 times 36. Oh, look, 36 is a perfect square. So the square root of 36 is just 6. Root 2, nothing can happen there. So it's all done. Oh, look, there's still space. Let's do one more. X squared is equal to 300. Square root of both sides. X is equal to root 300. It's not a perfect square, but guess what? If I do 3 times 100, the square root of 3 times the square root of 100, do you see that the square root of 100 is just 10? And the root 3 is not, anything can happen with that, so we just leave it as that. So 10 root 3 is my exact answer. It's my simplified radical. Good practice on those extra ones.